Good morning, ladies and gentlemen. My name is Ulisses Sperandio, and I'm the president of BRATECC. BRATECC's objective is the promotion and advancement of commercial trade and investment between Brazil and the state of Texas, the entry door to the US market, done by way of conferences, seminars, meetings, missions, publications, educational and social activities. And throughout 2020 and early 2001, our main means of communication has been webinars, such as this one. Similarly, we also support the US companies based in Texas interested in doing business in Brazil. Our focus is traditionally the oil and gas industry, but we have expanded to other areas such as agribusiness and also strategic areas as needed, such as infrastructure and SpaceCon and whatever areas we deem as strategic or needed for the business to continue between the two countries, or state of Texas and Brazil more specifically, where we provide equal level of support in all those areas. We rely on our extensive network of member companies that can provide the necessary support to start your business in the US, such as law firms, accounting houses, immigration support, and we can also provide physical space, such as offices and warehouses for your company to start in Texas if you like. BRATECC can therefore provide access to an extensive network of organizations and companies which are members based in Texas, such as the Brazilian Consulate in Houston, the Office of the Texas Governor, the AmCham, which is the American Chamber of Commerce in Brazil, the Greater Houston Partnership and the Port of Houston, the major oil and gas companies based in Houston in Texas, such as Exxon, Chevron, BP, Schlumberger, Showest. We also have access to bank members such as Bradesco, FTI, Matos Filho, and Mayer Brown law firms. And one of our newest members, Sapura Navegação Marítima, who recently joined our member ranks, and many other companies. We are this year commemorating 20 years of BRATECC's existence, and we are proud to be able to continue our support to the business communities of Brazil and Texas. We seem to be finally coming out of the more than a year of no public events, and therefore I would like to highlight something that's coming soon. I'm sure you're aware the OTC will be happening in August, presential of OTC. It's probably not going to be exactly the way it was previously, with some modifications and adaptations, but it will be presential. And therefore, BRATECC will hold two events during that week. We will have the Minister Bento Albuquerque, Brazil's Secretary of Mines and Energy, and the President of Petrobras, General Joaquim Silva y Luna, on Monday, August 16, for a cocktail reception organized by BRATECC. So I encourage you to start planning and putting in your calendars. And then on August 18, which is a Wednesday, we will hold our traditional BRATECC breakfast. And we will have, it's already confirmed, the Admiral Rodolfo Saboia, who is the Director General for ANP, the Brazilian regulator for Agência Nacional do Petróleo, with an exciting presentation, including the upcoming bid rounds in Brazil for 2021. So today's objective is to provide you with a comprehensive information and case studies on asset integrity and risk mitigation through SINFLEX, the structural integrity of flexible pipes. And today, we have Antonio Antunes, who is an associated partner in CENTRIC Energy, and he will moderate two excellent speakers talking about case studies in asset integrity and risk mitigation through SINFLEX. Before I pass the microphone to Antonio Antunes, I will introduce Antonio to our audience. Antonio is a good friend of mine during our many years in Schlumberger, and he is currently an associated partner in CENTRIC Energy. Antonio brings over 20 years of experience in multiple segments in the oil and gas industry, holding extensive knowledge on business development, sales leadership, merger and acquisitions, and general management with a successful international track record. He's been managing and growing business in the offshore and onshore drilling and production areas of the E&P industry in complex markets at multiple locations with companies such as ABB, Vector Gray, and Cameron Schlumberger. Antonio holds a bachelor's in mechanical engineering from the Industrial Engineering College, FEI, São Paulo, and an MBA in business management from Fundação Getúlio Vargas. Antonio, please go ahead.
Thank you very much, Ulisses, for your kind introduction. I hope you all can hear me well. Thank you also for the BRATECC team that made this important webinar possible by providing remarkable support to CENTRIC and SIMEROS. CENTRIC, a proud member of the Brazil-Texas Chamber of Commerce, BRATECC, is a young company that started its journey back in 2019, based in Rio de Janeiro, adding later in 2020 international reach through presence in Houston, Texas. The company relies on over 80 years of oil and gas industry experience from its founders and associates, bringing strategic business development, representation, and commercial consultancy on both domestic and international oil and gas grounds. One of our key partners that we have the pleasure to represent and work with is SIMEROS Technologies. SIMEROS is a high-end, 100% Brazilian engineering, products, and services provider, focused on flexible pipe and control umbilical solutions under both conventional and harsh subsea applications. SIMEROS stands out today as one of the most knowledgeable companies in the segment, excelling on research, developing and deploying innovative solutions to the most difficult challenges for oil and gas production. Today, along with BRATECC, we are glad to have the opportunity to get SIMEROS presenting and discussing about integrity management of flexible pipes, its challenges, and innovative solutions developed. With all that said, it's my pleasure to introduce SIMEROS, herein represented Mr. Fabiano Bertoni and Henrique Rigon. Mr. Bertoni is the co-founder of SIMEROS, and he has been acting as a director of the company since its foundation. He holds the degrees of mechanical engineer and master's in material science by the Federal University of Rio Grande do Sul. Mr. Rigon works in the capacity of R&D engineer for SIMEROS, based in Scotland, UK. He also holds a mechanical engineer degree by Federal University of Rio Grande do Sul. With that, Mr. Bertoni, the stage is all yours.
Thank you, Antunes, thank you very much for the introduction. Good morning or good afternoon, everyone. My name is Fabiano Bertoni. I'm a director at SIMEROS, and I'm in charge, I'm in front of technical and commercial department. On behalf of SIMEROS, I would like to thank BRATECC for the opportunity and the organization of this webinar. Starting our presentation, I would like to start with a question. Have you heard about SCC CO2, how it affects flexible pipes, and how mitigate it? Well, today we have brought our SINFLEX program, which means structural integrity of flexible pipes that have some initiatives regarding SCC CO2 mitigation. Next, please, Henrique. Let me go into more details about flexible pipes. Firstly, about the definition. The API standard defines subsea flexible pipes as a structure composed of different layers and materials forming a unique pressure containing conduit. Flexibles are extensively used in offshore oil and gas projects, from shallow to ultra-deep water production applications. The key advantages of the flexible pipe technology can be summarized as customized engineering and design, practical storage and the transportation in reels, shorter lead time, and easier installation compared to other solutions. Next, please. Now, I would like to show how a common flexible pipe design is. The standard design of flexible pipes consists of metallic and polymeric layers that have their own functionalities. The main pipe layers, explaining going from inside to outside, are carcass, which is responsible to sustain external pressure. Internal pressure sheath, there is a sealing layer that prevents fluids from coming out. Pressure armor, a structural layer that supports internal pressure. Tensile armors, in charge to sustain the actual loads. And external pressure sheath, another sealing layer that prevents fluids from coming in. So the multi-layer pipe structure results in an equipment that has superior structural resistance and leak-proof efficiency for a safe oil and gas production application. Okay, next, Henrique, please. As you may know, despite of being seen as field-proven technology, flexible pipes have some vulnerabilities manifested by different failure modes. While most of them are manageable and predictable, some of them still demand further investigation. That is the case for the corrosion and corrosion fatigue failure mechanisms, which can affect the structural metallic layers. First of all, it is very important to know where the pipe annulus is located, the definition of pipe annulus. As you can see in the picture, the pipe annulus is the region highlighted in green, located between the polymeric sealing layers, representing internal and external pressure sheath names. Okay. Inside the annular region, we have the pressure and tensile armor layers, both made by high-strength carbon steel wires. These structural layers are subjected to SiCO2 failure mechanisms when a certain type of corrosive environment is formed in the pipe annulus. Next, please. Okay, thank you. Let's talk about the main subject of this presentation, SiCO2. It means stress corrosion cracking by CO2, a failure mechanism well known by the industry. However, the SiCO2 was not fully mapped by the flexible pipe industry as a critical risk until the recent application in production fields with high CO2. One evidence was the accidents in the Brazilian ultra-deep water fields at the end of 2016 and the beginning of 2017 that led the Brazilian National Petroleum Agency, ANP, to issue a safety alert for the industry. Back then, the first assessment pointed out SiCO2 as the root cause leading to catastrophic failures of the injection, risers, and flow lines. As a result, all Brazilian pre-salt oil production was put at risk. These occurrences sounded an alarm and a call for an industry-wide task force to address some questions such as SCC CO2 mechanism, criticality, and comprehensiveness, and what the boundaries of occurrences are. What we know today is that the main ingredients that trigger the failure mechanisms are a wet annular environment with water and carbon dioxide, CO2, the stress state of the structural armors, the material susceptibility of metallic layers to corrosion cracking, and the exposure time under the influence of pressure and temperature. Besides that, the uncertainties regarding the speed of damage initiation and failure propagation led to several uncharted operational risks. In other words, it's a silent and invisible failure mechanism that can substantially reduce the pipe service life from hundreds to less than a dozen years. Next, please. Thank you. Now we can briefly explain how SCC CO2 takes place. The SCC CO2 in flexible pipes occurs mainly due to a mixture of permeated corrosive gases, including CO2, and an annulus wet environment with water and oxygen. Additionally, the corrosion susceptibility speeds up the process. As I said before, SCC CO2 needs a wet environment to take place. But how can the annulus get flooded? Well, basically, we can point out two situations. Permeated water vapor coming from production fluids that condenses inside the pipe annulus, and another recurrent situation regards the annulus flooding by seawater due to water tightness loss in end fitting parts, end fitting external seals, or through thickness damage in the external sealing sheath. All this generated by pipe design mistakes or pipe mishandling. Next, please. Now that you understand what happens in the annulus environment, let me talk a little bit about our solutions to help the industry mitigate the SCC CO2 risk. SIMEROS is an engineering company for testing, monitoring, and structural integrity solutions of subsea pipe systems. We are leading some initiatives together with the operators Petrogal Brazil, Galp, and Petrobras, and the main pipe manufacturers in order to better understand and carry out actions to pursue the definitive solution to avoid SCC CO2 in unbounded flexible pipes. Here in this slide, you can see a diagram showing how SIMEROS is dealing with the SCC CO2 issue. Our approach starts with what we call field experience. It can be summarized as initiatives to collect data from retrieved or installed pipes that were exposed to a potential SCC CO2 environment in operation. SIMEROS understands that field data is a baseline for establishing proper experimental assessment protocols and assertive field monitoring campaigns. Also, the field data corresponds to factual evidence which should be considered as a guidance for pipe manufacturers to start the reevaluation of the entire pipe development cycle. Following our strategy, the results from experimental assessment and the constant data gathering coming from operational inspection and monitoring feed the pipe design updates, new guides for material selection, and the adjustment in the manufacturing process. Besides that, a suitable ancillary design can play an important role in the integrity management of flexible pipes by enabling safe access to the annulus for pipe inspection, real-time monitoring, and field intervention for decreasing corrosion severity. The success of the mentioned initiatives will converge to the expected SCC CO2 definitive solution for conventional flexible pipes. Finally, for each diagram item, SIMEROS is carrying out initiatives to understand and propose mitigation solutions that will be shown next. Now I will talk a little bit about the pipe dissection program. Pipe dissection program follows SIMEROS approach of field experience basis. Pipe dissection is an initiative to investigate the SCC CO2 related field occurrences. It's important to mention that SIMEROS has a long-term contract with the main Brazilian operator dedicated to obtain the maximum amount of data from pipes retrieved from fields with high CO2 content. First of all, an engineered-based procedure has been developed and implemented to collect information and create a robust database. Then the post-treated data can be cross-linked to evaluate and compare the impact of operational conditions in different pipe structures and applications. The main dissection steps are GVI, general visual inspection, dimensional measurements, non-destructive testing, residual stress measurements, material properties testing, and material characterization. As a result of the dissection process, it's possible to evaluate the aged material properties, to assess the actual residual stress levels in the structural armors arising from pipe manufacturing process and operational loading history, generate a distribution mapping of SCC CO2 occurrences throughout the pipe length, radius, and layers, and generate a statistical data survey regarding the main crack features, such as crack length, shape, position, and others. Please, Henrique, could you change the slide? Continuing presenting experimental assessment initiatives, this project was born to reproduce as closely as possible the operational field conditions in an industrial lab scale, defined by us as Lab Twin. The primary objective is to develop SCC CO2 degradation mechanism in a controlled environment. The initiative aims to shed a light over some complex gas permeation properties that takes place in the annulus boundaries. Remembering that the annulus is defined as the region enclosed between the internal and external sealing barriers. Along with our partners, SIMEROS is carrying out the challenging task to assemble 22 full-scale samples in a lab twin setup, where the pipes are submitted to near real flow line field conditions. The lab twin setup includes controlled bore chemical content, pressure, and temperature, external pipe pressure and temperature. And besides that, the testing matrix considers a combination of 3 different pipe manufacturers with 2 different pipe structures representing production and gas injection application, and also 3 different aging times, 12, 24, and 36 months. The proposed setup will result in a permeation process that will deliver a characteristic field annulus environment for each sample under laboratory monitoring. The project includes protocols for laboratory instrumentation, monitoring, and dissection procedures in order to obtain the maximum expected results. The most relevant outcome is related to the generation of experimental basis to calibrate permeation models based on annulus building up pressure behavior, annulus environment content throughout the exposure time, and pressure shift permeation rate. Additionally, the project aims to reproduce the SCC CO2 failure mode in lab under controlled conditions from initiation until failure. Finally, an evaluation about the effect of the harsh environment in the pipe layer material in different aging levels will be done. Well, finishing this slide, now I will pass the word to my colleague, Henrique Rigon, who will present other initiatives to complete the presentation of our strategic approach. Henrique, the screen is yours.
Thank you for the introduction, Fabiano. Hello, everyone. So following the mentioned initiatives in experimental assessment, SIMEROS is investigating the relationship between SCC CO2 and dynamic loads. SCC damage can be exacerbated by other failure mechanisms, which represents one of the major concerns in the industry. The main concern is that SCC CO2 can quickly initiate damage, which, combined with dynamic loads, may speed up the damage propagation up to the catastrophic failure of the structural armor layers. This scenario compromises the safety of dynamic risers operating under high CO2 content, especially when annular flooding is a possibility. We created a project to address these issues, which is a joint effort among Petrogal Brazil, Galp, Petrobras, and SIMEROS. The scope of this project is to perform 6 full-scale tests and a set of material level analysis within 36 months. Pipe samples that were exposed to SCC CO2 during operation were retrieved from the field and will be the core study of this project. These pipes have a high probability to have damage initiation in the structural layers due to the SCC CO2 phenomenon. A dissection process takes place after receiving the samples in order to evaluate the actual degradation state of the structural armors and to confirm the predicted damage. The dissection then delivers a complete defect mapping that is the basis for the following steps of the project. After the dissection of the retrieved pipes, we will carry out several experimental assessment campaigns, from material level up to full-scale tests. The goals of these campaigns are to evaluate the crack propagation rate in the presence of different types of defects, to explore the effect of overload cycles as an option to inhibit crack propagation in the field, to develop and implement inspection and monitoring techniques that can detect the presence and growth of defects, to investigate and measure the proportion of damage due to SCC CO2 and the proportion of damage due to fatigue corrosion, to estimate the remaining service life, and also to update the safety factors from the dynamic test data. This project has started in the beginning of this year, and we are at the commissioning phase of the testing program. I will now briefly present the solutions that SIMEROS can offer today for the oil and gas market to mitigate the SCC CO2 issue. Pipelicon stands for Flexible Pipe Annular Control Manifold. It is a non-intrusive and modular system designed for unbounded flexible pipes that allow the access and management of the annular region of the pipe without interfering with its structure or its production flow. The system was born to address one of the many flexible pipe weaknesses, that is the premature corrosion of structural layers due to the unknown annular environment that forms during operation. Together with Petrobras Brazil, Galp, and Petrobras, SIMEROS went from concept design to a fully operational prototype within only 18 months, qualified to operate in ultra-deep seawater levels of external pressure. The Pipelicon system is installed between two end fittings without requiring any modification of either end fitting or flexible pipe. Its circuit is connected to the adjacent annular regions, allowing for complete control of its flow. With a privileged annular access, the Pipelicon system can provide innovative features during operation without interfering with the production flow, such as an automatic relief of the annular pressure, the detection of annular flooding, the monitoring of the annular pressure buildup, the connection of the annular regions of adjacent pipe segments, allowing for a unifilar annular circuit, the injection of corrosion inhibitors in the annulus, the purge and flushing of the corrosive environment in the annular region, and the sampling of annular fluids for further content analysis, such as chemical composition and permeation analysis. The Pipelicon system was built with reliability and safety in mind, fully compliant with the best practices and standardized subsea systems, with redundant flow control valves and barriers to guarantee water tightness during operation, and a maintenance-friendly interface with fully replaceable safety components and monitoring gauges, all compliant with standard ROV tools. After going through strict laboratory qualification tests, the Pipelicon system is ready for deployment and will be installed in Petrobras P66 platform, located in the Brazilian pre-salt fields, later this month. Pipelicon will connect two flow line segments under 2,300 meters of water depth. This project was so well received from the market that SIMEROS is a nominee for the National Petroleum Agency Technological Innovation Award, the main oil and gas innovation recognition in Brazil. Pipelicon is an independent ancillary device that is attached in completed pipes onshore or offshore bases. SIMEROS already developed a permanent solution for pipe monitoring, including all of the Pipelicon features, together with pipe structural integrity monitoring. This is SIMEROS Smart End Fittings. All of the Pipelicon technology is embedded in our proprietary Smart End Fitting solution. SIMEROS Smart End Fittings is a result of years of research and development. With a privileged access to the pipe layers during assembly, SIMEROS end fitting enable a direct and proper instrumentation of the pipe layers and annular environment. It is a key component for the forefront structural integrity assessment of subsea flexible pipes, a valuable technology to monitor the service life consumption of offshore assets. Since our end fittings are tailor-made for the application, they can be installed on any flexible pipe of any manufacturer in both onshore and offshore bases. Retermination or retrofit is currently known as a procedure to remove damaged segments of a pipe. However, SIMEROS believes that retermination can be much more than that. It is a great opportunity to evaluate the actual service life consumption and upgrade the pipe's performance through the installation of key ancillaries, such as the Pipelicon and SIMEROS' own smart end fittings. Following our initiatives for field monitoring, SIMEROS has introduced to the market a solution for top riser annulus inspection and monitoring, MATS, the Mobile Annular Testing System. MATS allows a real-time survey of the top riser annulus. MATS offers several features, such as the annular integrity assessment, annular free volume measurements, a permeation rate analysis, sampling and chemical content identification, injection of corrosion inhibitors. These services can be performed in several different stages of the pipe's life, from installation up to its retrieval, with a periodic assessment done according to the risks identified in operation. Currently, MATS is running a permeation assessment campaign, monitoring risers that can be subjected to the presence of CO2 in pre-salt fields, one of the ingredients of stress corrosion cracking failure mechanism. Inspection and monitoring techniques are powerful tools to assess the structural integrity of flexible pipes. However, such techniques are heavily dependent on an accurate calibration. Due to the suitable environment created by the set of ongoing activities, SIMEROS has a unique positioning to increase the pipe understanding through testing and dissection procedures, resulting in opportunities to improve the available techniques or calibrate new ones. To have an idea, in the next 2 years, SIMEROS has over 150 opportunities to perform inspections and monitoring inside of our dissections and full-scale test programs. We are receiving different retrieved pipe structures with field-initiated effects, and we're using them to calibrate inspection and monitoring techniques that are currently under development. We challenge our specialists to predict the pipe state before the dissection takes place. After the dissection, the results are then used to validate the inspection prediction and to support deviation and adjustments. The majority of tests that SIMEROS has performed are destructive, which means that they subject the flexible pipe to loading conditions that lead the pipe to failure. Each event is registered and characterized as a signature of the pipe failure behavior. All treated information forms a solid database with failure signatures that allow us to better understand the field data coming from implemented inspection and monitoring systems, and is a baseline to improve procedures and develop new techniques. Our current developments are focused on detection of annular flooding in pipes without the Pipelicon installed, and the detection of damages and defects in the metallic layers of the pipe, including the carcass, pressure, and tensile armors. In order to further help improve the safety of the oil and gas industry with regards to the SEC CO2 phenomenon, SIMEROS is assisting the technical review of international flexible pipe standards, API 17J and 17B. In combination with our know-how and technical board, we are helping to consolidate the knowledge acquired so far by addressing this critical failure mode of unbonded flexible pipes. In this sense, SIMEROS is carrying out some initiatives regarding pipe design, such as numerical models for gas diffusion in sealing polymer layers, and annular environment development prediction through our in-house software. Local analysis to accurately identify the stress state of structural layers, combining with fracture mechanics to better estimate the remaining service life and safety factors. We also have a step forward in material selection to minimize the polymer permeation and improve metallic resistance against corrosion. And finally, we have new pipe design concepts proposition that is a result of all of our other initiatives. Now I will pass back the stage to my colleague Fabiano for a few concluding words. Thank you very much.
Well done, Henrique. Thanks a lot. So I also would like to thank the audience for your attendance. We really appreciate your attention. And to finish our presentation, we bring again our strategy diagram with all presented initiatives in place. SIMEROS believes that the SCC CO2 can be minimized or even eliminated through a well-implemented program of integrated management for flexible pipes. And additionally, together with the usage of smart ancillaries and pipe design improvements. We are sure that SCC CO2 has brought an impact to the flexible pipe industry and additional risks for operators that use this technology. However, the field-proved robustness of flexible pipes designed for over 50 years of successful application, we are sure that engineering presents alternatives to overcome this problem. SIMEROS has presented an approach based on our experience, where we believe that it is an efficient way to help the flexible pipe industry to take control of SCC CO2 and go to even further demanding application. Thank you very much for your attention again, and we will share our contacts in the next slide. And we are glad to answer your questions.
Thank you very much, Fabiano and Henrique. We still have a good 14 minutes for a Q&A. Let me remind all the attendees to place your questions in our Q&A box in your screen. And if we happen to do not have time enough to answer that in here, we will take it internally, and we're gonna answer that as soon as we can. Very nice presentation, very interesting topic. Let me start off with it's a open question to you, Fabiano and Henrique. What's your take on operational safety and vision of the future of the application of flexible pipes in challenging production scenarios, such as ultra deep water, in the presence of SCC CO2, considering, for example, the materials and the engineering technology currently applied and existing in the market?
Okay, good question, Antunes. Without a doubt, SCC CO2 is a failure mechanism that it must be considered, and that carries risks that must be managed. The flexible pipe design concept is very robust, as we said, allowing for rapid design changes, material selection, and manufacturing process changes from design, material selection, and manufacturing process. As we have already talked about in the presentation, we are sure that with an integrated set of actions to improve calculation models, qualification tests, and the application of a structural integrity management will place the flexible pipe as a solution for ultra deep water oil and gas production. In other words, what we are saying is that with design adjustments, more resistant materials application, and intelligent systems that enable risk monitoring, the flexible pipe remains in the game in a competitive way.
Okay, thank you. So again, thanks for the audience. A lot of questions coming in. Let me take one here. Peter is thanking you guys and congrats for the presentation. What is the odd that the insertion of the Pipelicon, that's a Pipelicon related, what's the odd of the insertion of the Pipelicon between the EFs actually adds one more source of water intrusion into the annulus instead of suiting the objective of annulus monitoring?
Okay, I think I can take this one. So that's thank you for the question. It's a good question. The Pipelicon system was designed to have several barriers against water intrusion in the annular region. So today we have several different double or even triple barriers against water intrusion in any operational modes of the Pipelicon. So either if you're doing a maintenance of a safety system, or you are just doing some certain operations with the valves, everything is at least twice, there's at least a double barrier towards the external environment. The Pipelicon system itself, it went already through very strict laboratory tests. It withstand up to 2,500 meters of water depth of external pressure without any sign of leakage. So we're pretty confident that we actually increase the reliability of the current systems that we have today on the end fitting, where you only have just the vent valve. Instead of just having a vent valve, we have also other safety systems in place. So thank you for the question.
Thank you, Henrique. So questions are pouring in. That's very good sign. A lot of questions around the SCC CO2. Let's go back to that particular subject here. Let me take this one here. Have you identified the root cause for the observed SCC at high CO2 partial pressure? Is it a magic CO2 pressure that must be exceeded?
Yes, I can take you this one. This is very interesting question. Is what we are trying to answering since we started all the initiatives. Of course, the SCC CO2 is a time-dependent failure mechanism, and we need time to observe the behavior, the failure initiation, even accelerating the tests at lab. So it's a question of time, and we hope to answer this question sooner. We are running several tests, considering several types of pipes and several characteristic field conditions, and all the samples have a lot of instrumentations on board. So we expected to have this the answer for this question sooner.
Right. Thank you very much. I have one here that it talks about yet another subject you guys touched on your presentation. That is, what exactly is the difference between the SIMEROS lab twin system, and as we all know, we have a lot of digital transformation happening in the industry right now, right? So what's the difference between SIMEROS lab twin system and the other digital solutions, such as digital twins that we hear a lot these days?
I can take that one. We were actually inspired by the digital twin concept when we created the lab twin. The difference is that in digital twin, the checks are performed through a computational model. So in the lab twin concept, we actually use a representative segment of the real asset to conduct representative tests, sometimes even in an accelerated way. So we change the temperature, we change the pressure, so that we can accelerate the failure mechanisms, so that we can evaluate in the lab. What we do is that it differs because the lab twin is something that you can actually monitor and inspect using laboratory techniques. So it's cheaper and more reliable than if you were to do an inspection and a monitoring offshore, for instance. And it differs between the digital twin because the digital twin is really, how can I say, it's really dependent on the boundary conditions that you impose. So if you have good boundary conditions, the digital twin is is a choice, but more often than not, you need to have a reliability and a confidence in your boundary conditions and in your monitoring system for the lab twin, for the digital twin to work. And this is what we mitigate with the lab twin, by having a near real situation and a near real inspection using our lab monitoring systems.
Got it. Thanks for the answer. I think let's just keep on the lab twin arena, and there's another question here from the audience. So I guess what's the expected delivery time for lab twin? I mean, what's the time frames that SIMEROS work along with the lab twins initiatives, I would say?
Yeah, we just started the commissioning. We just finished the commissioning of the lab twin, considering 22 full-scale samples. And we hope that we are planned to establish 12, 24, and 36 months to evaluate the impact of the harsh environment in the samples. So during this period, we stop the aged process, and we will perform a dissection process to verify the impact of the environment in the pipe and pipe materials. So lab twin is implemented in SIMEROS and is ready to perform other types of tests. The idea, the concept is reproduce the field at the lab. Once the instrumentation, the monitoring is much cheaper compared to the offshore instrumentation, inspection, and monitoring. So basically, we are ready to reproduce at the lab, considering all techniques, all the laboratory techniques. We can reproduce as closely as possible the field conditions and evaluate the structural integrity of the samples at the lab, and respond some questions and help the operators to make decisions.
Okay. Let me get another one. We still have 3 minutes to go here before closing comments. Let me get another question here. This one. Has SIMEROS carried out full-scale tests involving flexibles from all the major flexible manufacturers?
Yes. Our JIP, Joint Industry Project that we are running, involve the main manufacturers of pipes, the main suppliers of pipes.
Okay, thank you. I take this one here. Can you elaborate on the material selection based on your presentation? The audience, the person that is asking, understood that you believe the carbon steel is still the only, is still one option for high CO2 applications?
No, of course. There are many options for other type of materials, but this will require a dedicated study and possibly a qualification program. But other grades of steel can be applied, and the other grades are resistant to SCC-CO2. I don't know if we don't know in which level, but probably can put the flexible pipe or flexible pipe life above the surface life envelope.
Okay. So let me go ahead and take the last one. And I do thank the audience for participating. Again, all unanswered questions will be answered at the soonest. Last question here. So far, it seems the flexible pipe failures occurred in Brazil pre-salt region and related to SCC-CO2 failure mechanisms are mainly in gas injection pipes. In your view, is there any particular reason for that? Also, failures have been identified in both dynamic, suspended, pipe region and static in seabed pipe region. Is there any region along the pipe length being identified as more susceptible to SCCO2?
Okay, the failures occurring in the injection pipes, the explanation is because the high content of CO2, high pressure, the high strain of the structural layers, so the susceptibility of the metallic materials. So it's a combination of facts that lead the failures. And answering the question about where SCO2 takes place firstly, I would say we are checking, we are verifying through dissection program, and what we are seeing that they can happen in several positions, and we cannot ensure what is the position that starts. We are mapping, and we expected to have a statistical analysis to identify the critical zones, but can be touchdown point, flow line closely to the well, or even in SAG hog position. There are many possibilities that we have already identified.
Perfect. Well, thank you very much, Fabiano and Henrique, for your presentation. That was a very interesting information shared with all of us. From my end, I thank you, the audience as well, to participate. And with that, I hand the word back to Ulisses for the closing notes. Thank you very much.
Thanks, Antonio. I join Antonio and thank our truly knowledgeable speakers, Fabiano, Bertoni, SIMEROS, and Henrique Rigon, for a very technical and practical presentation on SINFLEX. It was very thorough. We thank all our members for their participation and continuing engagement in BRATECC, allowing us to reach the extraordinary mark of 20 years in business, as well as the interest of all our audiences and attendees. I remind you all to check our website for upcoming events of June and July, including our summer business mix coming out of hibernation and our 2 events during the OTC week. So I'm just gonna repeat what I said earlier on. So on Monday, August 16, we have a cocktail with Minister Bento Albuquerque, Brazil's Secretary of Mines and Energy, and the President of Petrobras, General Joaquim Silva Luna. And on Wednesday, August 18, in the morning, we'll have our traditional BRATECC breakfast, where we will have the Admiral Rodolfo Saboia, the Director General for ANP. With that, I close this event. Thank you very much for your attendance. Thank you very much to the presenters. And thank you all for the interest in BRATECC.